Hey everybody, for this video we're going to talk about ionic compounds, binary ionic compounds, and I have these megablocks that are going to represent the different charges of the ions. So like for aluminum it's a +3 charge, so there's 3 little pegs here. For example, like chlorine is a -1, or fluorine or iodine or bromine, so it's got the 1 peg here. So this helps you to know how many of the charges need to mix up or go together. So you always need a positive and a negative. So I'm going to start with aluminum here. So aluminum is a +3 charge. Now phosphorus has a charge of -3, so the phosphide ion is a P -3. So because these two are the same, +3, -3, they actually are going to even out, so that the chemical formula for this is going to be ALP. So you don't need to write the 3's if they're the same, because they're the same. So it's just actually a 1-to-1 ratio. So for every 1 aluminum, you'll have 1 phosphorus. So what if the charges were different? So if I have aluminum, but I have magnesium. So magnesium is a +2 charge. It's not going to work. Oxygen. Okay, so oxygen is a -2 charge. So notice how it didn't work with the magnesium, because you can't have 2 pluses. It has to be a plus and a minus. So with my aluminum being a 3+, and oxygen being a 2-, so for the aluminum needs to go on the top because metals are written first. So aluminum has 3 pegs and oxygen only has 2. So how are we going to even this out? It means that we're going to need multiple. So to build this, I can put another oxygen here, but I'm also going to need another aluminum, and then another oxygen is going to even that out. So see how I need 2 aluminums and 3 oxide ions to even out the charges here. So I could also have just crisscrossed the 3 and put it down here to make it be the subscript of the O, and put the 2 to make it be the subscript of the Al. So this compound is called Al2O3, and we call that aluminum oxide. All right, let's try another one. Here is sodium, and we'll use sulfide. Okay, so sodium and sulfur. So sodium is a +1, and sulfur is a -2. So you can see that sulfur needs 2, and sodium only has 1 to give. So you're going to need 2 sodiums for every 1 sulfur. And again, you can take the 2 and put it here, and take the 1 and put it here, and this compound is going to be Na2S. We don't write the 1's, so it's just going to be Na2S, and that's called sodium sulfide. So you just put the names together. Let's try calcium and chlorine. All right, so a calcium ion is a +2, and a chlorine is a -1. So can you see what's going to happen here? The calcium needs 2. Chlorine's only got 1 to give. So you're going to need 2 chlorines for every 1 calcium. So this 2 goes here, this 1 goes here, CaCl2. So that's what we call calcium chloride. All right, so how do we do this in a synthesis reaction? So one of the ones we did last week was with magnesium and oxygen. So see how the magnesium is already a +2 and the oxygen is a -2? These go together in a 1-to-1 ratio. So the formula for magnesium oxide is just MgO. But what about if it was different? So let's look at sodium with oxygen. So in a synthesis reaction, you have a singular element plus an element that is also by itself. So what we want to create here is sodium oxide. So if we just put these two together, so the oxygen's already a 2, if we just put these two together and called it NaO2, that's not accurate because we don't need 2 oxygens. We need 2 sodiums. So what you have to do when you put these two together is not just write it on the other side, you need to figure out what the charges are going to be when you crisscross them. So the product here is going to be Na2O. But then that's still not right because we still have to balance it. So because there's 2 oxygens over here, there is only 1 oxygen over here, so we know we're going to need 2. And then that creates 4 sodiums. So this over here needs to be a 4. That's a very terrible 4. So the final balanced chemical equation for this would be 4 sodiums plus O2, just 1 O2, yields 2 Na2O, which is sodium oxide. So let's try that in another example. I'm going to do calcium plus chlorine. I just did this one actually. Ca plus Cl2. So remember that Cl is one of those diatomic elements that needs to exist together. This one is actually going to be CaCl2 because it already needs that. And that's already balanced. All right, so try practicing some of the synthesis reactions. When you do that, make sure that you have the product is going to be coming from the chemical compound naming, not from the equation.